Hello everyone. Uh, in this lecture, I will explain how to develop one of the most important tools that we can use in descriptive statistics. We will learn how to develop a histogram, and a histogram is a visual display of the frequency distribution. So the use of histogram is the same as the stem and leaf. So we use histogram in order to see the distribution of the data. And the histogram can be used for both for uh, counting data. So if you remember, counting data means uh, data that start from 0, 1, 2, 3, 4, and so on and so forth. And with counting data, you cannot have negative value and you cannot have fraction or decimals. So with counting data, you cannot have -1, -1.5, you cannot have 10.5, 0.5, 3/4, 7/6. No, you cannot have that in the counting data. So for example, of the counting data is the number of defect that we find from a batch of products. So we may have 0 defect, we may have 1 defect, 2 defect, 3 defect, 4 defects, and so on and so forth. And the histogram can also be used for continuous data. So with continuous data, we can have negative value and we can have decimals or fractions. So with continuous data, we may have -1.5, 3.4, we might have 100, we might have 7, we may have 7.5, we may have -7, we may have 5, 5.4, 3, 2.5, and so on and so forth. So an example uh, of the continuous data is maybe the weight, volume, and the temperature. That's They are examples of the continuous data. And the histogram can be used for both. We can use histogram for the continuous data, and we can use the histogram for the uh, discrete or counting data. Okay. Uh, let's see an example of how to develop a histogram. Okay. Now I'm gonna start with a histogram for the continuous data. Okay. So in order to develop a histogram for the continuous data, we start with uh, counting the range of the observations, and then we continue with we we calculate the number of intervals, because with the histogram you're gonna have intervals, and then you need to determine the width of the intervals, and then we need to to decide the interval boundaries, and then above each interval we need to draw the histogram. So I'm gonna give you an uh, so a histogram. Okay, it is something like this. Okay, it has a vertical axis and it has a horizontal axis. The vertical axis is the frequency. Okay, the frequency means how many observations that we have in the interval. So in the horizontal axis you have what the observation about. For example, the observation is about the volume of something. So you're gonna have interval. So in the in the horizontal axis, you need to label the interval. So we may start the interval from 0, right? Okay. So maybe here we have 4, and here we have 8, and then 12 and 16, for example. Now here, from 0 to 4, we call as the interval number 1. So this is our first interval. Okay. From 4 to 8, this is your second interval. Okay. And from 8 to 12 is your third interval. And as you can see, for each interval, we have what we call as the lower bound and upper bound. Okay. And the upper bound of the first interval is the lower bound of the second interval. The upper bound of the second interval is the lower bound of the third interval. So it is like this because we're gonna develop the histogram for continuous data. So that is why you have a continuous intervals. That is why you have the upper bound of the first interval is the lower bound of the second intervals. Now let's assume that we have several observations. So we have data here, we have data, so many data. Okay, we have so many observations. Okay, now the thing that we need to do is we need to determine the frequency of each interval. So from 0 to 4, how many observations that we have? Or maybe we have 2 observations. So we plot it as a rectangle. Okay, so the observation that we have from 0 to 4 is 2. Okay, and then from 4 to 8, okay, and then we plot it. Maybe we have 6 observations. So that's how we develop a histogram. But remember, so we use here the interval as what we learn in calculus as an interval. Okay, so we use the same notation of interval as what we see in mathematics. Okay, so see that interval 1, 0 to 4, this means, so we assume let say that x as the variable, so our variable here is volume, and say that volume as x. Okay, so the notation for interval of the first interval is 0 less than x and x less than or equal 4. That's your first interval. This is first interval. What is your interval number 2? Your interval number 2 is 4 less than x and x less than or equal 8. Okay, This is your second interval. And see that. So if we have number 4 as our observation, by using the notation of interval like this, 4 will not be counted twice in the frequency. So 4 will always be in the first interval, and 4 is not belong to the second interval. Why? Because 0 less than x less than or equal to 4, meaning that 4 is included in the first interval. In the second interval, 4 less than x and x less than or equal to 8, meaning that 4 is not included in the second interval. Okay? And the notation for your third interval will be 0 less than x and x less than or equal to 12. It is your third interval. So by doing this, okay, it will be clear that a number will belong to what interval. Okay, there will not be a number or an observation that will belong to more than one intervals. Okay, so this is very important. You need to remember this. Okay, now in developing a histogram, the first thing that we need to do is to develop what we call as the we need to develop a table first, and the table is called as distribution frequency table. Okay, and then based on the table we develop the histogram, the graph or the picture for the histogram. Okay, now the next question is how many intervals that we need to make. There is no fixed rule for that. Anyone can say any number for the number of intervals that he want to use, but there is a common formula that we can use, that the number of interval equal 1 plus 3.3 times log n. Okay, where n is how many observations that you have, n means the sample size. Okay, now and how long is the interval? So the length of the interval it is number of interval. Oh no, it is the range divided the number of interval. Okay, I think I need more space here. I will write somewhere else. So so here we have the number of the interval. Now we need to decide the length of the interval. It is range divided the number of interval. Okay. And you know what range is. So range is x maximum minus x minimum. So the maximum value of the observation minus the minimum value of the observation. That's the range. Okay, And here, for the example here, the length of the interval is 4. Okay. And one more thing that you need to know, that when you are making a histogram, you need to be careful in deciding the number of the interval and the length of the interval, because you have to include all the observation that you have in your histogram. Okay. So you cannot leave any observation now not counted in your histogram. Okay. Now let's see an example. So I'm gonna coming back to the PowerPoint. So we have some data here. This is the data of the string of the material. Okay, and because it is the string of the material, it is a continuous data. Okay, so here we have the data, and we need to construct the histogram for the data, and based on the data we will determine the quartile 1, the quartile 2, or the median. Remember, median is the quartile 2, and the quartile 3, and the IQR. So in the quartile range and the modus for the data. Okay, now let's do that. Here I already copied the data. Okay, here the data. So I think I'm gonna do this in a new worksheet. I'm gonna copy and paste. Okay, this is the data. Okay, remember, the first thing that we need to do is we need to calculate the range. And what is range? Range is the maximum value of data minus the minimum value of data. So the max minus mean of this. Okay, this is the range. Okay, and then we need to decide the number of the interval. Okay, how many intervals that we have? So we need to do 1 plus 3.3 times log. Okay, in Excel, log number, the number is how many of the data. We have 80 data, but I'm just gonna count the data. So I'm gonna count the data. Okay, so count means you count how many the data are. Okay, comma, close parenthesis, and it is asking for the base, and we use the log using the base of 10. Okay, so we have 7.3 intervals. So you cannot have 7.3 intervals. Okay, the thing that you need to have, so we can have 7 intervals, we can have 8 intervals, 9 intervals, but you cannot have 7.5, 8.5 intervals. So we're gonna round it up. So we're gonna decide that we're gonna have 8 intervals. Okay, now the length of the interval, okay, so the length in the interval will be the range divided by the number of the interval. So it's 21. Okay, so I'm gonna round it into 22. Okay, so it will be easy. Okay, now the next thing that we need to do is we need to develop that table that I mentioned before. So we're gonna have 8 interval. So I'm gonna put number here, is the number of the interval 1, 2, 3, 4, 5, 6, 7, 8. We're gonna have 7th interval. So we're gonna have the lower bound of the interval, and then we're gonna have the upper bound of the interval. Okay. Now see from the data, what is the minimum value of the data? Mean. I'm gonna put it here. Mean. Okay. What is the minimum value of the data? Mean of the data is 76, and the max of the data, I'm just gonna say it, the maximum value of the data is 245. So since the minimum value of the data is 76 and all the data must be included in the histogram, so I'm gonna put 75 as my as the lower bound of the first interval. Okay, so I'm gonna have here as what we have here before. Okay, so we're gonna have here the notation for the interval. So 75 must less than x, and x must be less than or equal to another number, and that number is the upper bound. What is the upper bound? The upper bound is the lower bound plus the length of the interval. I need to lock this because I'm gonna copy it down. Okay. Okay, I'm just gonna copy the upper bound of the interval. So you have all 22s, it's okay, but remember the upper bound of the first interval is the lower bound of the second interval, so we just put them as the same, and then we just copy and paste. Okay, and just copy and paste the formula over there, the formula for the interval over there. So here we can see the upper bound of the interval is 251 and the maximum value is 245. So we are sure that all the observation that we have here will be included in our histogram. Okay. Okay. Now, so we are done in setting up the interval. Now we're gonna calculate the frequency. Okay. So we need to calculate, we need to count how many observation that is bigger than 75 but less than or equal to 97. Okay. Okay, so if you do this manually, so you so you need to count it manually, but with Excel we can use the formula count ifs. Okay, count ifs. Okay, and it will ask you for the criteria range 1. So it is asking for the range. This is the range of the observation. We need to lock it because I'm gonna copy it down, and then the criteria. What is the first criteria? X must be bigger than 75. So I'm gonna put quote sign, okay, bigger than, and then the n sign 75. Okay, so because here I mean X bigger than 75, and then comma, it is asking for the range again. I'm gonna put the range over here. I'm gonna lock it. So I lock it by putting $sign, and I do that by pressing F4, and then criteria 2. What is the criteria 2? So X must be less than or equal 97. X less than or equal 97 here. Okay, and then I'm gonna close the parentheses, enter. So there are 3 observations that is less than or equal 97 but bigger than 75. But the next thing that I need to do, I just copy it down. Now we need to check the total. So the total should be 80. So we need to sum. Yep, there are 80 of them. And then we need to calculate the cumulative frequency as usual. So the cumulative frequency of the first interval is the frequency of the first interval, which is 3. And for the next interval will be the cumulative frequency of the previous interval plus the frequency of that interval. Okay. So we have 80 in total. So I think we are almost done with the constructing the histogram. So now so in Excel, the thing that we need to do now is to insert. We go, so histogram is a type of the column chart. So click that, and then we need to select the data. So we need to select the series name. It will be the number of the interval, so first, second, and third interval, and then the frequency. Okay. Let me see. That's fine. Okay. So I'm just gonna delete this. Okay. So since, remember here when I explained in the beginning, so the histogram must be, you see that the upper bound of the first interval is the lower bound of the second interval. So here what we need to do, we need to put no space between the bars. Okay, so I'm gonna let's see what we're gonna do here. I'm just right click, format data series. Okay, and then I'm gonna put no gap. Okay, now there is no space between the bars, and then I'm gonna add data label. So here I know that in the interval number 1 I have 3 observations. In the interval number 2 I have 5 observations. Okay. Okay, now if you want to put let's see border color, so I'm just gonna put solid line, and I'm gonna put the color of black, so it is clear now the border of the intervals. So I need to label the horizontal axis and the vertical axis. I'm just gonna go to design, let's see, layout, axis title, let's see, vertical axis, it is the frequency, okay, f, small f, and the horizontal axis, I'm gonna go to here, and it is the number of the interval. Okay, and the unit of that, okay, it is just the number of the intervals. Okay, so this is the histogram. Now I'm gonna coming back to the slides. It is asking for Q1, median, Q3, and the quartile range, and the modus or the mod. Okay. Now we gonna calculate the Q1. Remember, what is Q1? The location of the Q1. Okay, the location of the Q1, it is the n plus 1 divided by 4, right? That's the location of, so the Q1 is the n plus 1 divided by 4th of the data. So how many data that we have? We have 80, right? We have 80 plus 1 divided by 4. So it is the 20.25 observation. Okay, see here from your histogram till the interval number 3 you have 18 data cumulative. So for sure your first interval is not in the your first quartile is not in the interval number 3, but it will be in the interval number 4. Okay, it is in interval 4. Okay, now what is the value of Q1? Okay, now so we know that it is in interval number 4. What is this 1 unit? The value of 1 unit in interval 4. Okay, what is it? 1 unit in interval 4. 1 unit in interval 4 is the length of the interval. What is the length of the interval? 22, right? It is 22. Right, so it is 22. Okay, divided by the frequency of that interval, and that is 24. Okay, that is 1 unit of interval number 3. Okay, number 4, sorry. Okay, now let's the Q1. Okay, let's see if I do it correctly. 4, 24, yes. Okay, 22 the length of the interval. Okay, now what is Q1? So interval number 4 starting with 141 plus, okay, oh, I think I made a mistake. Yes, I made a mistake in the term in deciding the location of here. It is okay. The location of Q1 is in the 20.25 observation, and 1 unit of interval 4 this much. That's okay. Now I think I'm good. So what is the value of Q1? So it's 141 plus what is 1 unit of interval number 4, this one, times, remember, till interval number 3 we have 18 data, right? But the location of the Q1 is the 20.25 observation. Okay, so see the quartile number 1 must be in the 20.25 minus 18 of the observation in interval number 4. Okay, this is it. So this is your Q1, 143.06. Okay, so I repeat. So we know that the location of interval number 4, the location of the Q1 is in the interval number 4. Okay, it is the 20.25 observations. Okay, but we know that till observation number 3 we have 18 observation, and therefore in the interval number 4 the Q1 is it's 20.25 minus 18 observation in interval 4. Okay, and that's why in the formula here the value of Q1 is the lower bound of interval number 4 times how much is 1 unit in the interval number 4 times the difference between 20.25 and 18, which is 2.25, and 2.25 is the location of the quartile 1 in the interval number 4. Okay, I think that is clear. Now we calculate interval number a quartile number 2, or the median. Okay, location, so it is the 2 times n plus 1 divided by 4. That's the location of the quartile 2. It is the 40.5 observation. Okay, and it is in what interval? See, it is 18, the cumulative till interval number 3, but the cumulative frequency until interval number 4 is 42. It is in 40.5. So quartile 2 is also in interval number 4. Okay, it is still in interval. So 1 unit in the interval number 4 is, okay, it is still the same. Now what is the location, or what is the value of Q1? So it be the lower bound plus 1 unit of interval number 4 times, remember, it is in 40.5 observation minus, so till interval number 3 you have 18 observation, so minus this, minus 18, so it is 161.625. That's the Q1. Now we are calculating for Q3. Now the location of Q3, it is 3 times n plus 1 divided by 4. Okay, C is 60.75. See, it is 40 until here, 42 until here, is 633 until interval number 5. So it is in interval number 5. Okay, now what is 1 unit in the interval number 5? So it is the length of the interval, which is 22. It is the same, divided by 21. Okay, now what is, sorry, I need to change this into Q2. I need to change this into Q3. So it is in interval number 5. What is the lower bound of interval number 5? So 163 plus the length of 1 unit in interval number 5, okay, times the location, which is 60.75 minus the cumulative frequency of the previous interval, which is the interval number 4. Okay, so that is it. So it should be 5 here. Okay, Q3 location interval 5. Okay, Q3. Okay, I think we are good. So the Q1 is 143.1, the median is 161.63, and the quartile number 3 is 182.64, and the IQR, the range of the interval, is the Q3 minus Q1. Okay, it is 39.6. Okay, now the last thing that it is asking is the mode. Okay, so we need to coming back to the table, or to the what, the histogram. C, interval number 4 has the highest value of frequency, which is 24. So this is interval number 4. It is the highest frequency, right? 24. So the modus will be in this interval. Okay, so since it is continuous data, so the modus will be the midpoint of the interval. So I'm just gonna calculate the midpoint. So I'm gonna midpoint. Okay, the midpoint of the interval. So the midpoint will be the lower bound plus upper bound divided by 2. Okay, so since interval number 4 has the highest frequency, which is 24, so the modulus is 152. So our modulus is 150. Let me see, 152. Yes, I'm just gonna put equal this kind. Okay, so I think this is it on how to develop a histogram and how to get the quartile 1, median, and quartile 3 and modulus in the histogram. Thank you very much.